some more factoring examples just so we feel comfortable with quadratics, grouping, and our favorite polynomial identities. So, first thing I always want to check while factoring is if I have a greatest common factor between all of my terms in my polynomial. Here I do not, and then I look at the number of terms that I have. Since I have 4, I'm going to use grouping. So I'm going to find 2 terms that have a GCF. My first 2 terms, I have a greatest common factor of k squared. So if I factor that out, what do I need to multiply k squared by to get 7k to the third is 7k. When I say, what do I need to multiply k squared by to get 8k squared? I need to multiply by 8. Then I look at my second group and find that my common denominator in my second group is 8. So a positive 8 I'm going to be dividing out. So 56k divided by 8 is 7k. 64 divided by 8 is plus 8. The key in grouping is to check if inside my parentheses is the same. I have 7k plus 8 in both of my parentheses, so I can make that one of my factors. I create my second factor by using what's on the outside of my factors. So I have k squared plus 8. I have to double check that I can't factor further inside my parentheses, which I cannot, and I have my factored form of my polynomial. Next, I have 4k to the 4th power plus 60k squared plus 224. I'm going to check for my greatest common factor, and it is 4. So I'm factoring out of 4 from each of those terms to be left with k to the 4th plus 15k squared plus 56. I then think about my identities, and I do not have an identity that this would match, so I'm going to use this as a quadratic. The reason I can use this as a quadratic is because if I have k to the 4th power, what would I be able to multiply by itself to get k to the 4th power? And I can multiply k squared times k squared to get k to the 4th. So I'm just going to keep those factors down there for later on, and I'm going to use our beautiful method of factoring quadratics to figure out what my k and m would be. So I do 1 times 56 is 56, and what 2 numbers multiply to 56 and add to 15? My answers would be 8 and 7. So I'm going to go ahead and fill them into our factors. So now we have 4 times k squared plus 8 times k squared plus 7. Can we factor any of those further? We cannot. And we have factored our quadratic. Now we have 64 plus 125k cubed. And this is where our fun begins. So, we have to think about our identities because 1, we don't have a greatest common factor. 2, we can't use the quadratic method. So now I'm going down my list of identities. And since I have k raised to the third power, I'm going to think about my cubes. So since it's a sum, I'm going to see if I have a sum of cubes. The sum of cubes rule is x cubed plus y cubed is equal to x plus y times x squared minus xy plus y squared. So I want to be able to rewrite 64 plus 125k cubed as something being cubed plus something being cubed. So what could we cube to get 64? And our answer would be 4 cubed gives us 64. Then we think about what cubed gives us 125k to the third power. So first think about 125, and that is 5, because 5 times 5 times 5 is 125. Then to get k cubed, we just need to multiply k by itself 3 times. So 5k cubed gives us 125k cubed. Now this looks more like the form x cubed plus y cubed. So in order to factor this, we're going to, wherever we see an x, have 4, and wherever we see a y, have 5k. So we're going to start off with 4 plus 5k times 4 squared minus 4 times 5k plus 5k squared. We can do just a little bit of simplifying here. You can't do anything in here with the 4 plus 5k. But instead of writing 4 squared, we're going to write 16. Instead of writing minus 4 times 5k, we're going to write minus 20k. And instead of the quantity 5k squared, we're going to write plus 25k squared. Going to look at these two factors, and can we factor any further? So here we have our factored form of 64 plus 125k cubed. And our last beautiful example. This is going to be a little bit more difficult, but nothing my little smarty pants can't handle. So, GCF, we don't have one. 2, identity, no. 3, can I quadratics? Well, can I multiply something by itself to get k to the 8th? Yes, I can. K to the 4th power. So now I need to think about what two numbers multiply to 144 that add to negative 25. This means that I'm going to have 2 negative numbers here. Those 2 numbers are negative 16 and negative 9. So I'm going to fill those into my factors. K to the 4th minus 16 times k to the 4th minus 9. Oh, you thought it was over, silly kids. I need to double check my factors. can I factor k to the fourth minus 16 again? You're right. The answer is yes. But we don't have a GCF that isn't quadratics, and that means I need to think about my identities. Since I have to the fourth power. So, we are going to think about the difference of squares, because we have a difference. And the difference of squares is x squared minus y squared can be factored into x plus y times x minus y. So here, I am going to have k squared is what is being squared, minus 4 squared is what's being squared. So if I rewrite that, I have k squared minus 4 times k squared plus 4. I need to do the same thing for k squared minus 9. I'm going to get k squared minus 3 times k squared plus 3. Is it over?
Yep.
No, it's not. No. We have another difference of squares, which we get k plus 2 times k minus 2. And bring down all of the rest of our factors. K squared plus 4, that we do not have sum of squares, so we can't factor that. K squared minus 3 times k squared plus 3 is our final answer. You're all great. I love you. See you tomorrow.
Too much.
Too much.